Water providers endeavor to deliver clean, clear water to customers' taps. But source water doesn't always begin that way. For water systems relying on surface water or groundwater under the direct influence of surface water, water entering the treatment plant often contains suspended particles, which make water appear cloudy. This cloudy appearance is referred to as turbidity and can contain organisms that may threaten public health. From source water to throughout the treatment process and into the distribution system, turbidity is monitored closely by water utilities. Turbidity represents a measurable amount of particulate material that is in the source water. The majority of the particulates are not hazardous in and of themselves, but may contain, harbor, or mask the presence of pathogens. Pathogens are biologically harmful microorganisms or infectious agents that might be in the water that can cause disease within a host. For safety's sake, utilities work on the idea that all surface waters may contain pathogens that will need to be removed. Naturally occurring particles, sand, clay, and other bits of fine particulate matter can shield the pathogens from the disinfectant, making the disinfectant less likely to destroy or inactivate the pathogen. So, turbidity removal serves a dual purpose, removing possible pathogens and allowing the disinfectant to work more effectively. Turbidity can be comprised of and/or transport organic materials that may react with disinfectants to create disinfection byproducts, or DBPs. DBPs may pose health risks to the public and must be closely monitored. Therefore, turbidity removal is a very important part of a multi-barrier approach to protecting public health. Turbidity removal is accomplished via a number of treatment strategies, including pre-treatment, traditional media filtration, and membrane filtration. Monitoring turbidity before and after treatment gives an indication of how well the treatment processes are working. The primary devices used by operators to monitor turbidity are turbidimeters and particle counters. Turbidimeters measure the clarity of water by reflecting light off particles in the water. It's important to understand that turbidity is not the same as suspended solids, which is a measurement of the weight of suspended material in a sample. Turbidity is an optical property caused by suspended particles as light is passed through a sample. Simply put, turbidity is measured by shining a light through water and measuring the amount of light that is reflected off the particles in the water. So, a higher turbidity would be the result of more particles in the water reflecting the light, and a lower turbidity would be the result of less or fewer particles in the water reflecting the light. As light is passed through a water sample, it is reflected by the individual particles that cause turbidity. A detector, such as a phototube, is located 90 degrees off of the main light path. The amount of light measured by the detector is expressed in nephelometric turbidity units, or NTUs. The 1942 U.S. Public Health Service Drinking Water Standards established a limit of 10 NTU for water turbidity, which was later lowered to 5 NTU. The goal was to achieve an acceptable aesthetic quality for drinking water. The 1974 Safe Drinking Water Act decreased the limit of filtered water turbidity from 5 to 1 NTU when researchers discovered particles causing turbidity or protecting microbial contaminants from disinfection. The regulation is designed to ensure harmful pathogens like Giardia and Cryptosporidium are removed from drinking water. These pathogens are more resistant to disinfectants, so it is necessary to physically remove them from the water rather than relying solely on disinfection. Turbidimeters have long been used in water utilities to track source water quality, monitor treatment process performance, and ensure that regulations are being met. By installing turbidimeters at key points in the treatment process, operators are able to track turbidity levels as water moves through the plant. Typically, turbidity is measured for raw water influent and after clarification in individual filter effluent and then the final plant effluent. To test water with the standard turbidimeter, at least 100 milliliters should be collected in a clean glass or polyethylene container. After shaking the sample, an operator transfers sample water to a clean measurement chamber, which is placed into the turbidimeter. Here, a light beam and detector measure turbidity. A variation of the standard turbidimeter is the online turbidimeter. Here, a stream of water flows through a chamber and turbidity is measured continuously. Most treatment plants do both, as the operator-obtained samples are used to check the validity and accuracy of the online analyzer to verify that the calibration is correct. Water providers must make sure their turbidimeters are properly maintained and regularly calibrated. This helps ensure consistent and accurate measurements. Calibrations are made by using a sample with a known turbidity level. This is known as a standard solution. The standard is placed in the turbidimeter and the equipment is adjusted until it gives a measurement equal to the turbidity level of the standard. This is similar to setting a tare or zeroing out a scale. To ensure accurate and consistent measurements, operators should ensure that sample containers and chambers are kept clean and free from scratches. Gas or bubbles in the sample will also interfere with turbidity readings, so it may be necessary to degas samples prior to tests. Sample containers should be dedicated to one source. For example, containers used for raw water should not be used for treated water and vice versa. Continuous flow turbidimeters have an automatic system for removing bubbles from the water to prevent interference with readings generated by the light beam and sensor. Although turbidimeters are used extensively, they do have some limitations. Turbidimeters measure the particles in the sample as a whole, but little additional information is given. Turbidity is a regulated parameter in a surface water treatment plant, whereas particle counts are not. Turbidity measurements must be reported to the proper regulatory agency each month, and there are maximum allowable levels that must be met. Turbidimeters tell operators how much turbidity is in the water, but they don't provide more specific information, like the size, shape, or composition of particles in the water. The instrument used by water providers to size and count particles in water is the particle counter. Particle counting has been long used in medicine, manufacturing, and electronics, and is today a valuable tool for water supply operators. Particle counting gives more detailed information than does turbidity, within similar measuring. For example, if you have a reading of one turbidity unit in a water sample, that reading could have been created by one large particle, or it could have been created by 1,000 small particles. While turbidity is a qualitative measurement of the amount of particulate matter in water, particle counters provide quantitative data on the size and number of the particles themselves. The additional information allows operators to make adjustments to treatment process. Particle counters provide more information than turbidimeters because particles are individually sized and counted. In a conventional filtration plant, the small submicron particles generally break through first, followed later by Giardia-sized particles. Therefore, particle breakthrough is often a good predictor of turbidity breakthrough. There is lots of research demonstrating that turbidity removal is a good surrogate for Giardia removal in a conventional filtration process. In fact, that is the underlying basis for the treatment technique requirements of the Surface Water Treatment Rule. Research has shown Giardia-sized particles may pass through the treatment process with no increase in filtered water turbidity readings. That's because small concentrations of micron-sized particles scatter very little light. Here, a closer examination of the particles is necessary. Particle counters are most useful on the effluents of a filter. One can generally see the breakthrough of small particles before one can see breakthrough of turbidity. So often an operator will watch a trend of particle counts along with a trend of turbidity. Often one can see a rise in particle counts before a rise in turbidity, and then an operator knows that the filter probably has to be backwashed. Particle counters combine particle detection technology with electronic counting technology. They operate by passing a very fine stream of sample water past a laser or light source. The light that is blocked or diffused by passing particles is measured by a photodiode or sensor, and the signal is interpreted by a computer. The most popular types of particle counters used by water utilities are batch and online. With batch particle counters, sample water is collected in a container and the particle counter's sampler draws water from the sample to create flow through the sensor. Online particle counters draw water continuously from the sample location through tubing that's connected directly to the sensor. A flow controller is required to regulate the flow of the sample. The most important requirement for using online particle counters is to maintain a specified flow rate. The flow must be constant and at or near the sensor's calibrated flow rate. Manufacturers offer a wide range of flow rates. Particle counters should be calibrated to match the flow rate of the plant's selected sample point. Particle counters also need to be calibrated so sensors will provide accurate particle size and shape readings. This is done by using calibration spheres of known size and refractive index. Online particle count data can be expressed in total particle counts, volume concentration, differential counts, particle size distribution, log removal, and percent filter efficacy. Water professionals say the information particle counters provide can have a significant impact on the entire water treatment process. The pathogens utilities are generally most concerned about are Giardia and Cryptosporidium. They represent particles in the 2 to 10 micron size range. By carefully watching the number of those particles, an operator can optimize coagulant dosage to minimize the number of crypto and Giardia-sized particles that will pass out of the filter. Another important reason is that there isn't a universal standard for calibration of particle counters. There is an ASTM standard. All turbidimeters can be calibrated so that their results match. A water sample measured on one device will give the same result on another device. There isn't such a standard available for particle counters at this time. Despite the important information particle counters can provide, they are not yet used by all utilities for several reasons. Particle counters can be expensive and cost more than turbidimeters, and although they are in greater use, they are more complicated to calibrate, so additional training is needed. And currently, there aren't any regulations requiring the use of particle counters. Many water providers will use a combination of technologies to monitor the removal of turbidity and dangerous microorganisms. The information this equipment provides is a valuable tool in effective water treatment. Turbidimeters and particle counters help operators know exactly what is going on in the plant and helps them to respond quickly to any changes in the raw water supply or if there is a process problem. Turbidity measurements for incoming source water alert operators to changing conditions, allowing them to adjust treatment to best fit source water quality. Readings taken following clarification provide instant feedback on how effectively coagulation doses are working and serve as a benchmark to measure filtered water turbidity against. And post-filtration turbidity and particle counting are crucial in measuring overall treatment performance and the effectiveness of the filtration process. Turbidity measurements and particle counts also aid operators in optimizing chemical usage. In the long run, it really helps to save the utility money because it's one of the best ways to optimize chemical processes in the treatment plant. Undertreating water is a threat to public health as well as overfeeding chemicals. Using less treatment chemicals really does affect the bottom line. These measurements help operators achieve greater optimization of the coagulation, flocculation, and sedimentation processes. Close monitoring of turbidity and particle removal also aids in effective disinfection. Turbidity removal is paramount before significant disinfection, since turbidity or particles in the water can shield microorganisms and inhibit chemical disinfection from inactivating the pathogens. Now that the interim enhanced surface rule and the long-term enhanced surface water treatment rules are in effect, odds are that there will be minimal changes in turbidity regulations within the near future. All monitoring techniques have some limitations, and no single method can provide all the answers to measuring filter performance. However, turbidimeters and particle counters are invaluable tools in helping operators not only in day-to-day operations, but in long-term optimization. Every water supply operator's goal is to provide customers with dependable, clean water, safe from the dangers we can see and those we cannot.